Good morning. Thank you. And welcome to What's New in Screen Recording and Live Broadcast. My name is Johnny Tren. I'm a software engineer at Apple working on the ReplayKit team. Today, my teammate Alexander Suboten and I are really excited to talk to you about all the new upcoming features we have planned for ReplayKit this year. We've got a lot to discuss, so let's go ahead and get started. ReplayKit is a framework that allows developers to record their application's audio, video, and microphone content to a movie file that their users can then review, edit, save, or share with the rest of the world. ReplayKit also supports live broadcast. For applications generating content, ReplayKit provides you with all the tools necessary to stream your application's audio, video, and microphone content to a broadcast extension. For applications implementing a broadcast extension, ReplayKit comes equipped with easy-to-use Xcode templates that'll help your application stream ReplayKit content. ReplayKit records both audio and video in HD quality with low performance impact and minimal power usage. Privacy is a very big thing with us, so both recording and broadcasting comes equipped with privacy safeguards, such as user consent, as well as all recordings and samples that exclude system UI. Since the release of ReplayKit, we have seen some amazing adoption from developers all around the world. Applications like Galaxy on Fire, Vainglory, Call of Champions, and Modern Combat 5 are all using ReplayKit today to record and broadcast their users' experiences with the rest of the world. Last year, we introduced live broadcast with ReplayKit, and we are proud to say that ReplayKit now powers some of the industry leaders in mobile streaming. The support, adoption, and feedback we received from developers has been amazing. That is why this year, we're really happy to introduce ReplayKit 2. With ReplayKit 2, our goal is to bring ReplayKit to every user and every application. We've designed our new features to take ReplayKit beyond just gaming, enabling all developers to record and broadcast their users' experiences to the whole world. And to do that, the first thing I want to talk about is in-app screen capture. Look, we've already seen the amazing content your users have been creating with ReplayKit. With ReplayKit 2, we're introducing in-app screen capture, which is a powerful new API that's going to give you direct access to your application's own audio, video, and microphone content straight from ReplayKit. Our goal with ReplayKit 2 was to bring ReplayKit to every application. And to do that, we're making ReplayKit instantly available to every application on iOS. Previously, to use ReplayKit and to have an application using ReplayKit, you'd have to use our API. But now, users can record and broadcast their entire iOS screen experience straight from the new screen recording control found in Control Center. Also new with ReplayKit 2 is the ability to pair your application with a particular streaming service. Developers can now seamlessly integrate their entire streaming solution right from within their own application. Last year, we introduced front camera support for ReplayKit. This year, with ReplayKit 2, we're introducing fast camera switching, which is going to enable you to use both the front and rear cameras for additional video commentary. We've got a lot of new and exciting things to talk about, so I'm just going to go ahead and jump right in with in-app screen capture. In-app screen capture is a powerful new API that's going to give you direct access to your application's own audio, video, and microphone content straight from ReplayKit. This new API is going to open doors to new user experiences that just weren't possible before. But before we get into in-app screen capture, let's go ahead and take a look at how applications are currently using ReplayKit to handle recording. An application that's currently using ReplayKit will call into RP Screen Recorder to get the shared recorder instance. From there, you'll call start recording on the shared recorder instance, at which time the replay daemon will start to capture your application's audio, video, and microphone content, and create and manage a movie file just for your application. When you call stop recording on the shared recorder instance, replay daemon will communicate with the share and preview extension and instantiate an RP preview view controller. We'll pass that RP preview view controller back to your application so that you can present it to your users, allowing them to review, edit, save, or share the recording they just made in your application. With the new in-app screen capture, just like with recording, you're going to call into RP Screen Recorder to get the shared recorder instance. From there, you'll call Start Capture on the shared recorder instance, at which point the replay daemon will start to capture your application's audio, video, and microphone content. But instead of creating and managing a movie file just for your application, ReplayKit will send those audio and video samples right back up to RP Screen Recorder. A capture handler block is then called, and we'll send the audio and video samples right back to your application's process. Your application now has direct access to its own audio, video, and microphone samples straight from ReplayKit. Giving you direct access to your application's audio and video samples from ReplayKit will provide you with more flexibility and control over the content your users are already creating. Just like with recording, in-app screen capture captures audio and video in HD quality with low performance impact and minimal power usage. Again, privacy is a very big thing with us. So in-app screen capture comes equipped with privacy safeguards, such as user consent, as well as all samples excluding system UI. The API is simple and lightweight. So let's go ahead and take a quick look at it. Start Capture takes in two blocks, a capture handler block and a completion handler block. The capture handler block is called every time ReplayKit is ready to hand your application back a sample. We provide you with a CM sample bufferref, an RP sample buffer type, and an NS error. The completion handler block is called when start capture has completed, and will give you an NS error indicating to you whether or not an error has occurred during start capture. The stop capture also takes in the completion handler, which will also pass you back an NS error, indicating to you whether or not an error has occurred during stop capture. Let's go ahead and take a look at how we can use this in practice. Here, in our example, what I want to do is I want to take the samples that ReplayKit has given me, and I want to use it to write a simple movie file to disk using AV Asset Writer. So here, I have a method called didPressCaptureButton. Inside of it, I'm simply going to grab the shared recorder instance from RP Screen Recorder. From there, I'll call Start Capture, providing it a capture handler block and a completion handler block. Remember, I'm trying to write a movie file using AV Asset Writer with the samples we get back. So it's really important for me to know how I'm going to handle these samples. So let's take a closer look at the capture handler. Remember, the capture handler is called every time ReplayKit is ready to hand your application back a sample. We'll provide you with a CM sample bufferref, an RP sample buffer type, and an NS error. Since I'm using these samples to write a simple movie using AV Asset Writer, it's really important for me to know what type of samples I'm getting back from ReplayKit. Here, we have a switch on RP sample type that's going to do just that. If I get a sample buffer type that's video, I'm simply going to append that sample to my video input from my AV Asset Writer. If I get a sample buffer type that's audio, I'll append that sample to my audio input from my AV Asset Writer. And finally, if I get a sample buffer type that's for the microphone, I'll append that sample to my microphone input from my AV Asset Writer. And just like that, I am now handling all the expected types of samples I'm going to get back from ReplayKit. And I'm also using them to write a simple movie to disk using AV Asset Writer. Let's go ahead and take a closer look at the completion handler. Just like with recording, you want to indicate to your users that a capture session has currently occurred or is in session. So in our completion handler, we're going to simply call update the capture button with the error that we get back during our completion handler. This will allow me to update my UI and indicate to my users that a capture session has occurred. And that's it. That's all you have to do to start using this powerful new API. I want to take a minute to revisit how in-app screen capture is actually working. And I'd like to remind you that your application now has direct access to its own audio, video, and microphone content straight from ReplayKit. In our example, we use these samples to create a simple movie using AV Asset Writer. But you can do so much more with this. Now that your application has access to its own audio and video samples, you can create and manage videos right into your own application. You can even create a custom video editor and have it seamlessly integrated in the user experience for your application. Again, the goal of ReplayKit 2 was to bring ReplayKit to every application, not just gaming. Here, I have the same productivity app running on 2 different iOS devices. Now that I have access to my application's audio and video samples, just like with broadcast, I can encode these samples myself, and I can send them to my own personal server. From there, I can share my application's screen capture with any other instance of my application running on any other device. This just wasn't possible before, but it is now with in-app screen capture. These are just some of the examples of the new user experiences you can create using in-app screen capture. And we're really excited to see what developers are going to do with it. With ReplayKit 2, our goal was to bring ReplayKit to every type of application, not just gaming. And to do that, I'm really happy to introduce iOS screen recording and broadcast. iOS screen recording and broadcast is an amazing new user feature that's going to allow users to record and broadcast their entire iOS screen experience. Let's go ahead and take a look at how we can use this new feature. To use iOS screen recording and broadcast, you're going to first need to enable the screen recording control for Control Center. To do that, we're going to jump right into Settings and Control Center. From there, we'll be shown all these supported controls for Control Center. We simply add the screen recording control, and we start Control Center. And just like that, you're now up and running, ready to share your entire iOS screen experience. Thank you. To initiate an iOS screen recording, you simply tap the screen recording control. You are now recording your entire iOS screen experience. The status bar and our screen recording control will indicate to you that a recording is ongoing by showing you a recording indicator as well as the elapsed time for your current recording session. To stop the recording, you simply tap the screen recording control again. When the recording has been stopped, you'll be presented with a notification indicating to you that the screen recording you just took has now been saved into your Photos application. Tapping on this banner will take you straight to your Photos application where you could review, edit, or share the recording you just made. You can also 3D touch into our screen recording control, which will bring you straight to our expanded view, where you'll have access to the microphone settings, as well as the ability to start recording or to stop recording. Now, let's say I've just downloaded a broadcast application that supports ReplayKit live streaming. And I'd like to use that broadcast application to share my entire iOS screen experience. Well, that's actually pretty simple to do, because all you need to do is 3D touch into our screen recording control. You'll be taken to our expanded view, where all the applications that are installed on your device that currently support ReplayKit live streaming will be shown. You simply need to select the service you'd like to use and tap Start Broadcast. You are now broadcasting to the entire world your entire iOS screen experience. Just like with recording, the status bar and the screen recording control will indicate to you that a broadcast is currently in session by showing you the recording indicator, the current selected broadcast service, and the elapsed time for your current broadcast. To stop the broadcast, you simply tap the Stop Broadcast button. Now, you could record a video to teach your grandparents how to make that FaceTime call. You can even stream a video to teach your parents how to send that important email. Or better yet, You can now record a video to teach your kids how to find their favorite TV shows and movies in iTunes. It has never been easier to share your entire iOS screen experience. iOS screen recording and broadcast creates new user experiences with applications that are already using ReplayKit. So let's take a quick minute to talk about some best practices. iOS screen recording and broadcast has priority when it comes to ReplayKit. So if your application is currently using ReplayKit to record or broadcast, and the user initiates an iOS screen recording and broadcast, your application will be notified via RP Screen Recorder Delegate that your session has been interrupted. In this case, the recording will be discarded, and you should update your UI and notify the users accordingly. iOS screen recording and broadcast is an amazing feature, and one that we hope users and developers will use to create new, exciting iOS content. And to help you do that, I'd like to bring Alexander Suboten up to the stage to talk to you a little bit more about how we do broadcasting in ReplayKit.
Thank you, Johnny. Good morning. My name is Alexander Subotin, and I'm so excited to be here, talk to you, and share more details about our live broadcast API. ReplayKit enables applications to stream their content to third-party broadcast services directly from your iOS or tvOS device. On iOS, you can also include voice and video commentary using the microphone and a camera. And all this content is absolutely secure and only accessible for the broadcast service that you use. This is a high-level picture of how live broadcast really works. Over on the left, you see a player who at some point wants to broadcast his game Tower Dash to Mob Crush, which is a broadcast service. So Tower Dash communicates to the ReplayKit API to initiate the broadcast. And once that happens, ReplayKit will present some UI that allows user to pick the broadcast service. And that would be Mob Crush for us. And the broadcast starts. And once broadcast is running, ReplayKit will be providing audio and video samples to the Mob Crush app extension that directly talks to the broadcast service, and the viewers around the world can watch that live stream online. This is just a picture of how broadcast runs. And the way I want to describe it to all of you is I want to break it into parts, because if you are a client application developer, game developer, the only thing you need to do is to present some view controller, initiate broadcast, and a couple of other fairly simple steps. But I also know that some of you in this room are broadcast service developers. And we are going to walk through the process for you and talk about how do you actually implement those extensions. So starting with the client side and what the client application wants to do. For that, we have a fairly simple API that really wrapped up in those three classes. There's broadcast activity view controller, and this class is used to initiate a broadcast, and it presents this built-in UI where you select the broadcast service. RP broadcast controller allows you to manage the broadcast in your code, and you would usually wire it to some UI where user can start, stop, pause, or resume the broadcast. And the RP broadcast controller delegate is internal, and this is a delegate that is notified about different events during the broadcast. The broadcast can stop for some reason, there could be an error, or the broadcast extension may want to pass some information to the client app, and this is where the delegate also used. And now I'm going to stop here talking about this part of the picture, because last year we covered this API in depth in our session, Go Live with ReplayKit. So in case you have not adopted the API yet, please go to the app, and you can find the link to last year's session and learn more about that API. Now let's talk about the second part of the equation. If you're a developer of the broadcast service, how do you integrate your service so that you could stream the content created by all these players, games, and other applications? And the answer is these two extensions. The first one on the top is what we call broadcast setup extension. And its purpose is to present some UI where you can ask user to enter some information. You may want user to give a broadcast a particular name, or maybe login credentials, or anything else that you need to fire up your broadcast. And the second one is called broadcast upload extension. And the function of this extension is to receive the media samples handed by ReplayKit and encode them, create a video stream, and upload to the online service. Each extension is a separate binary that is installed on your device along with the broadcast app. So if you install the Mob Crash, you also get setup extension and upload extension installed on your device. And each extension runs in its own process independently from Mob Crash that contains extensions and Tower Dash that initiates the broadcast. So usually there are three processes, and the process of the containing app of the Mob Crash is never launched. And to help you get started developing new broadcast extensions, we provide very easy-to-use Xcode templates for both types of the extensions. And just add 2 extensions to your Xcode project, and you are ready to begin. And now let's talk about how you actually code all of this, starting from the setup extension. As I said, the purpose of the setup extension is to present this UI where user can enter the name of the broadcast or something. But it also has another important function. It can get some information about the client application, such as a bundle ID, the name of the application, or the icon of the application. And it can upload this information to the broadcast service so that the broadcast service could build an experience for viewers when the viewer comes to the website and he knows, here's this place where everyone playing Tower Dash. Here's the icon of Tower Dash. And also, the extension can request from this broadcast service a URL of that particular live broadcast happening on the website and share it back to the application so that the player could send it to his friends and get more followers. The view controller that implements this UI communicates to ReplayKit using a property called extension context. And the class of this property is a category of an extension context that has 2 more functions added by ReplayKit. The first one is load broadcasting application info, and the second one is complete request with broadcast URL and setup info. And the first one, as I said, it's used to get the icon and the name of the application. And here's a small code example of how you could do that and pass this information to the broadcast session. And the broadcast service, when it has this information, it can identify and index broadcast sessions, create channels, and build simple and intuitive user experience, or viewer's experience like this. The viewer comes to the app, and he has an icon and the name of the application. So when you're done uploading this icon and already collected all the information that you need to begin the broadcast, you should call the second one called complete request with broadcast URL and setup info. And the broadcast URL will be available to the client application as a property of the broadcast controller. And the setup info, it's a dictionary that you create inside this extension, and all the information you collected from the user, you put it to that dictionary, and it will be passed to the upload extension when the broadcast starts. You should also always provide an option for the user to cancel broadcast, and for that, you just use regular cancel request method of the extension context. Now let's talk about the upload extension. As I said, its function is to receive the media frames handed by ReplayKit in real time, encode them, create a video stream, and upload it to the broadcast service. If you create a new upload extension using Xcode templates, you would find a sample handler class like this in your Xcode project. And this is where you override functions that take care of events like the broadcast has started, stopped, paused, or resumed, and also the function called process sample buffer. And this is the one that you want to override to handle incoming media samples. This is where all the magic happens. You do upload, like encoding and uploading here. So when the broadcast starts, ReplayKit notifies extension that it will begin providing it with media samples. And ReplayKit is using the function called broadcast started with setup info for this. And here's a code example that shows you that you do receive the setup info as an argument of that function. And you could extract, say, name of the broadcast from the dictionary and pass it to the broadcast session. Or in case the broadcast has started from the control center, you could just let know the session about this fact. And now, let me zoom in on the process sample buffer function. ReplayKit provides the extension with 3 types of the media samples. Video samples captured from the screen, audio samples captured from the application. This is the audio your application is playing back right now. And the audio samples captured from the microphone. And you can use any technology to encode this media, but as a practical matter, we provide you a lower-level API called Video Toolbox. This is a framework that provides access to the hardware-accelerated encoding and decoding. All samples go to the upload extension and handled by the function process sample buffer. And that function should encode and upload the media samples. Here in this code example, we show you how you could use the Video Toolbox to encode the video sample. In your real code, you would also have to implement the callback to receive the encoded data, etc. But here, I would like to speak about the Video Toolbox because it's especially important when you do your video processing in the app extension, because app extensions have much lower memory limits compared to the foreground applications. And having access to this hardware-accelerated video encoding is vital for the ReplayKit upload extensions. And this year, we have great news. Video Toolbox is also available on tvOS now. So you can build highly optimized, very efficient extensions for both platforms. This is a high-level picture of how live broadcast works and who implements each part. Again, if you're a game developer, client application developer, all you need to worry about is just present a view controller, initiate, and stop the broadcast. And you could implement this API and be done by the end of this session. And if you are a broadcast service developer, there's little more work on your side. You need to receive the samples, encode them, and upload to the broadcast service. There's one more thing I need to go over before we finish with this part of the talk, is that so far we've been assuming that all the data flows upwards from the application to the online service, but indeed, it is also possible for the data to be flowing back from the online service to the application. And that could be some viewers' feedback, like the comments of the viewers, or likes, or any kind of data, number of viewers. And for that, we provide an API that helps you to deliver this information from the extension to the client application. And you would have to just put this data in a dictionary and use the function called update service info from within your extension. And that dictionary would be available to the application as a property of the broadcast controller. The name of the property is service info. And it's KVO observable, so you can monitor this and update the UI appropriately. This is it for the live broadcast API overview. And having all this information, you can build absolutely new products, given that you also can start the broadcast from the control center. You can build third-party screen mirroring or video sharing during the sharing of the screen during the video conference. Thank you, and please welcome Johnny back on stage.
Thank you, Alexander. So as Alexander has just stated, currently to broadcast your application, you would need to present to the user a RP broadcast activity view controller that allows them to choose a public service to broadcast your application to. Well, sometimes you don't want to broadcast your application to a public service. Sometimes you want your application to use your broadcasting service. Well, with ReplayKit 2 and broadcast pairing, you can do just that. Broadcast pairing enables you to fully and seamlessly integrate your entire streaming solution all from within your own application. Here, we have our budget application, and we have our conference application that supports ReplayKit live streaming and has implemented a broadcast extension. I want our budget application to stream exclusively to our conference application's broadcast extension. So to do that, I'm going to initiate a broadcast pair. Our budget application is going to call load with preferred extension on the class RP activity view controller. We'll get back an instance of RP broadcast activity view controller, much like we do with general broadcast initiation. But here's the main difference between broadcast pairing and general broadcast initiation. Because when you go and present that view controller, instead of the user being presented with a picker that allows them to choose a public service, they'll be presented with an alert that indicates to them your application's intent to use a particular broadcast service. Here, our budget application wants to stream to our conference application's broadcast service. When the user taps accept, ReplayKit will immediately launch the paired broadcast extension, allowing the user to input any information that might be important to their broadcasting session. When the user has finished inputting all their information, ReplayKit will start broadcasting to the paired broadcast extension. And just like that, our budget application is now streaming exclusively to its paired broadcast extension. Let's go ahead and take a look at the API for broadcast pairing. The API for broadcast pairing is very simple. It's a new class method on RP broadcast activity view controller called load with preferred extension. We'll hand you back an instance of broadcast activity view controller that you can then present to your users. Let's jump in and take a look at how our budget application is going to initiate a broadcast pair in a little bit more detail. Here, I have a method called didPressBroadcastPair button. Inside of it, I'm simply going to call load with preferred extension on the class RP broadcast activity view controller. We'll go ahead and get back an instance of RP broadcast activity view controller that, when we go ahead and present, the user will be presented with an alert that indicates to them my application's intent to use a particular broadcasting service. Once the user accepts, ReplayKit will handle the rest, and we'll start the broadcasting extension that's been paired. Broadcast pairing has been designed so that the broadcasting app and the broadcasting service are tightly coupled. So, initiating a broadcast pairing session, developers are going to have to supply the bundle ID for the broadcast extension. Users will also need to accept the broadcasting pair through the alert, which will be shown every time you wish to initiate a broadcasting pair session. Broadcast pairing allows you to seamlessly integrate your entire streaming solution all within your own application. Now, we know that creating replays and live streams with user commentary is a fantastic way to get new user engagement in your application, as well as generating a community around your application. That's why last year we introduced front camera support for ReplayKit, and which is why this year we're also introducing fast camera switching for ReplayKit 2. Fast camera switching allows you to change the camera feed in the camera preview view found in RP Screen Recorder to use either the front camera or the rear camera. The camera preview view found in RP Screen Recorder is a subclass of UI view, so it can be added to just about any application. Developers are responsible for UI elements that allow the user to present and dismiss the camera preview view, as well as UI elements that allow the user to switch the camera preview view. Let's go ahead and take a quick look at the API for fast camera switching. The API for fast camera switching is really simple. It consists of a new property on RP Screen Recorder called camera position, which is used to denote the current camera position for the shared recorder instance. Camera position is an enumeration RP camera position, which includes RP camera position front and RP camera position back, which is used for the front and back cameras respectively. Let's go ahead and jump into an example of how we can start using fast camera switching. Wow, that photo looked a lot better on a smaller screen. Here we have a function called show preview view. Inside, we're simply going to grab the shared recorder instance on RP Screen Recorder. From there, I'll grab the camera preview view for the shared recorder instance. Since the shared recorder instance and its camera view is a subclass of UI view, I'm simply going to add it as a subview to my view in my application. And just like that, we're now using the camera preview view and the front-facing camera for our video commentary. Let's go ahead and take a quick look at how we can use fast camera switching. Here, I have a method called didPressCameraSwitch. Again, I'm simply going to grab the shared recorder instance from RP Screen Recorder. I'm really interested in knowing what the current camera position is. So in our method here, we're going to check to see what the current camera position is. And whatever it is, I'm going to switch it to its opposite. So here, we notice that our camera position for our shared recorder is using RP camera position front. I'm simply going to set the shared recorder's camera position to be RP camera position back. And just like that, our preview view is now using the rear camera for its video commentary. It really is just that easy, and it really is just that fast. Fast camera switching will give you additional tools to provide your users with to create more engaging video commentary in the content they're creating in your application. Whew, we have covered a lot today. So let's go ahead and take a minute to recap. In ReplayKit 2, we introduced in-app screen capture, which is a powerful new API that's going to give you direct access to your application's own audio, video, and microphone content straight from ReplayKit. With iOS screen recording and broadcast, users can now record and broadcast their entire iOS screen experience straight from Control Center. We introduced broadcast pairing, which will enable you to seamlessly integrate your entire streaming solution all within your own application. And finally, with fast camera switching, you now have more tools to provide your users with to create more engaging video commentary. For more information about our session today, visit us at developer.apple.com. We are session 606. We hope you have a wonderful WWDC. Thank you.